Welcome back to Hamamatsu's TechBites. Next up, we have Kane, who will be introducing our InGaAs camera range. So Kane, why have you chosen to speak about InGaAs cameras today?
We touched on silicon-based CMOS cameras like the Fusion BT in the previous tech talk by Emma. These are really great options for imaging visible light, but of course there are lots of other types of light out there. Visible isn't the only kind. We all know about some of the more well-known types of light already, X-ray, microwave and radio wave for example, but I want to discuss InGaAs cameras in particular, which allow for imaging in the near and shortwave infrared and has its own unique set of advantages for imaging in some applications, such as thermography, in vivo imaging in life science and beam profiling.
What's so useful about the near infrared?
Near infrared actually has a surprisingly wide range of uses. Most optical communications nowadays is done in the near infrared, called the telecom wavelengths. And of course, there is plenty of research and industry working at these wavelengths to build and improve communication technology. There are also a lot of common materials out there that are opaque to visible wavelengths, but it turns out that in the right conditions, you can often see through them using near infrared. This has obvious uses for quality inspections to look inside things, non-destructive testing within industry, and also for biological imaging, particularly within the brain.
Can you tell us about the cameras themselves?
We can offer a number of different InGaAs cameras to suit any specific imaging needs. These cameras will typically have a 60% quantum efficiency from around 0.95 to 1.7 microns, and we offer two different sensor sizes to match a desired field of view. There is also a special deep-cooled version which is suited for imaging with long exposure times for situations where the amount of light being measured is low. All of these cameras, of course, can be connected through a standard USB interface, so it's quick and easy to use and come with all the necessary software included.
Can you give me some examples of near-infrared imaging?
Yes. So I mentioned biological imaging and telecom wavelengths just now. In biological imaging, near-infrared light is better able to travel inside organic matter than visible light, which allows you to image deeper within a sample than is typically possible with visible light and allows you to get more information from beneath the surface. This can also be used non-invasively in biological research or even in simple cases to see the blood vessels under the skin. From the telecom side too, there are also a large number of different lasers that emit in the near infrared. The human eye cannot see the light from these lasers, of course, so these cameras are enormously helpful for measuring the profile and size of the beam or even just for alignment purposes.
What about industrial applications?
Yeah, so to list off a few, we have non-destructive testing. So here, for example, with a tomato, we can use the camera to see beneath the skin for signs of damage and assess the overall quality. Here you can see the fruit looks normal under visible light, but in the near infrared it shows signs of damage, in this case from being dropped. The ability to see inside objects is also very useful for semiconductor inspection, so you can take a picture of a circuit board and see all of the traces on the board, including those that are hidden in layers under the surface. This imaging technique really has a wide range of uses. Even within art, for example, these cameras are regularly used for inspecting paintings and the like to look for hidden layers of paint and see what is found underneath. Hyperspectral is the buzzword for this, which makes all this possible. Our cameras are ideally suited to this form of imaging.
Are there any new releases on the way?
Great question. We just released some excellent new options in the InGaAs range, extending their sensitivity further into the shortwave infrared. These new cameras, the C16090 series, use specially designed sensors to give enhanced sensitivity at longer wavelengths, allowing for an increase from 1.7 microns now all the way up to 2.55. We expect to see a lot of new and interesting applications that we have not seen before at these newly available wavelengths.